Okay, boys and girls, I'm going to be working on two problems today, number 6 and number 7. On your books, it's page 285. I will be working on these two problems as an example of how to solve these type of problems in this lesson. Okay, so if I'm going to do this in my whiteboard just because I need more space. So number 6, I have number 6 here, 11 and 1/9 minus 3 and 2/3. So you can follow along in your book, um, or you can write it in your notebooks so that you can have as a reference as an example. So when I start this problem, which is subtracting fractions with whole numbers, here I have a little situation where, I cannot keep going because I need to have the same denominator in my fractions. This is okay. So 11 and 1/9 minus 3 and 2/3. So we were saying that we need to find the common denominator because it has to be the same. So maybe you are going to be able to figure this out mentally where you look at the 9 and the 3 and say, well, 9 is a multiple of 3. So I can use 9 as my common denominator. However, if you're still having trouble, then remember that you could always list them on the side. So I can write the multiples of 3, and I will write the multiples of 9, but first 3, and then so we have 3, 6, and 9. And I stop there, 9, because I already see that 9 is a multiple of 3. So I don't even have to find the multiples of 9 because I already found the common denominator, which in this case is 9. Okay, so what I'm going to do is now I need to find the equivalent fraction of 3 and 2/3. If my denominator was not 9, it was a different number, then I would have to find the equivalent fraction of both digits. But in this example, we only have to find the equivalent fraction of 3 and 2/3 because it does not have 9 as the denominator. So my first step here was, okay, and I'm going to write the steps so that you can see it. Step 1, find common denominator. Okay, now we're going to go to step 2. I'm going to find the equivalent fraction. Okay, ooh, fraction. Okay, so let's find now the equivalent fraction of 3 and 2/3. Let's do this in green. So let me take my math tool. I'm going to rewrite 3 and 2/3. And now to find the equivalent fraction, I know that I will be needing to find, I will be multiplying 2. I need to multiply 2 and 3 by the same number, right? And so in addition to that, I know that my denominator, oops, I put it there. My denominator needs to be 9. Now, don't forget to bring your whole number. This case is 3. Okay, carry it over. Okay, so I need to figure out now the numerator. I know my denominator is going to be 9. So I think 3 times one number equals 9. 3 times 3, right? 3 times 3 will give me 9. If I multiply the denominator by 3, I need to multiply the numerator by 3. So 2 times 3 is equal so 2 times 3 is equal to 6. So the equivalent fraction of 3 and 2/3 is 3 and 6/9. So now I'm going to subtract. Now I'm going to go to the next step, which will be to actually subtract. Well, the only thing is that to subtract, wait, I don't want it in that color. Okay. So I'm going to go ahead and subtract. I'm ready to subtract. Let's see. Let's do this here. Okay. I'm just going to do it here. And I'm going to do it in another color. Let's see. Let's do purple. Okay. So now I'm going to rewrite my subtraction sentence. Okay. I have 11 and 1/9, and I'm subtracting 3 and 6/9. Okay. I'm going to move this so that it's right under. Okay. Now, the problem that I have here, which we discussed during class, is that I cannot take away 6 from 1. My fraction on the top is smaller than the fraction or that I'm subtracting, and I can't do it. It's kind of like subtracting, taking away 3 from 2, or taking away 9 from 0. You can't. And in regular math, where there's no fractions, you will regroup. Well, in fractions, we call it renaming. We're going to rename it. In other words, we're going to take one of these whole numbers, okay? The 11, we're going to take a whole number out. That means that this will become a 10. And we're going to add that whole number to the fraction. But when we add the whole number to the fraction, we don't add it as a whole number. We need to add it using a fraction. So I'm going to add the fraction that equals to 1. Let me write this on the side so that you can visualize it. So 1 in this case is equal to any number over the same number is equal to 1. 10 over 10 is 1. 9 over 9 is 1. 3 over 3 is 1. 1,000 over 1,000 is equal to 1. But I want to use a fraction with the same denominator. So in this case, I will use 9 over 9. Okay? 9 over 9. So now I'm ready to add that 1, which is 9 over 9. Okay, let me move that a little bit higher. So now I'm going to rewrite everything. Okay, I'm going to rewrite it because, let's see, I'm going to rewrite it because I want it to be neat. Okay, so, oops. So I'm going to rewrite it. Okay, I have 10. That's my new whole number because I took away that 1. And now I need to combine 1/9 plus 9 over 9. I only add the numerator, not the denominator. Okay, only the numerator. So 1 plus 9 is equal to 10. And then the denominator, the 9, stays the same. And there was no change to the second fraction, so I just rewrite it 3 and 6/9. Okay, now I am ready to subtract. Let me put this a little higher. Okay, I am ready to subtract because now I can. So we have 10/9 minus 6/9. I only subtract the numerator. The denominator stays the same. 10 minus 6 is equal to 4, and the denominator stays the same. And now I subtract the whole number. 10 minus 3 is 7. And I know that it's already in simplest form. How do I know? Because I cannot divide by any number without getting both the numerator and denominator without getting a remainder. What that means, I cannot divide 4 by 4. I can divide 4 by 4 and get 1, but I cannot divide 9 by 4, which is one of the multiples. So I know that that is it. It's already in its simplest form, in other words. So 7, my answer is 7 and 4/9. Okay, I'm going to go through another example because I want to make sure that see enough examples. But I'm not going to go as slow as I did on the first one. On number 7, I have 6 minus 3.5. So I'm going to rewrite this on my whiteboard. My problem here is 6 minus 3.5. Now, see this one. Oops. This problem is a little different because it only has, I did that again. Okay, 6 minus 3.5. This problem the 6 does not have a fraction, but it's the same idea of renaming. Okay, so I'm going to write 6. Okay, um, basically it's like having 0 over 2 here. Okay, because that's equal to 0. And I'm subtracting 3.5. Gonna move this to the left. Okay, so this is where I'm gonna have to rename. I'm gonna have to regroup or rename the 6. So I'm going to cross out the 6, and now it becomes a 5 because I'm gonna take away 1. And I'm going to combine it with the fraction. So if you see here, um, I put 0 and halves just so that I can have a fraction, but this is equal to 0. Um, since there was no fraction here. So now what I'm going to do is add that whole number. So I'm going to write my 1 as a fraction and use 2 as a denominator. So I'm writing 2 over 2. And I'm moving 2 over 2 there. So I'm going to combine it before I'm able to subtract. So remember, I'm going to write it again because I want my math to look neat. So I'm carrying over that 5. And then I'm adding 0 plus 2 is 2, and the denominator always stays the same. So isn't that equal to 6? I have 5 and 2 over 2. 5 is the whole number. 2 over 2 is equal to 1, so it's the same thing as 6. But I'm just rewriting it like that so that I can take away 3.5. Okay, so now I'm ready to subtract. Okay, 2 halves minus 1/2. I'm only going to subtract the numerator. 2 minus 1 is equal to 1. And I keep the same denominator. And now I just subtract the whole numbers. 5 minus 3 is equal to 2. So my answer is 2.5. 6 minus 3.5 is 2.5. This one is actually a little easier. Don't get confused by the 0 over 2. That's the same as 0. Or you could have just put 6 and then taken 1 out from the 5 and written 2 over 2. That's another way to do it. Okay, so hopefully this works. It helps you. You will have some practice questions now for you to try.